Okay, section 2.3, slope. They have a nice little slope tree, which is kind of cutesy. Positive, negative slope, zero slope, undefined slope. Once again, should be review. Here we go. Rate of change is the measure of how one quantity changes on average relative to the change in another quantity. Some very basic examples would be miles per hour. Okay, how much money you make an hour, how many miles per gallon you get. Those are examples of rate of change. Now, slope is also a rate of change, but it's a special case. It's when your y-coordinates change in correspondence to your x-coordinates. I like to write this in a much simpler fashion. You don't have to write this unless you really want to. And I'm going to put M because M is the universally maybe not universally, but here in the United States, M is equal to change in y over change in x. And here's the kicker. Sometimes when we look at a graph, we call it rise over run. Okay, so that's kind of your basic slope review. That's it. All right, we can have slope in many different ways. Here's the most common way. You can have positive slope. If you were in my Algebra 1, I'd dig out Mr. Potato Head. Not really feeling like it right now. I think you guys, this is pretty much a review. This is zero slope. This is a negative slope. And slope that goes up and down, we don't say none. We say undefined. This word, you have to have this undefined. So in your notes, I'd have just the picture and the word. Picture, just a quick little sketch graph and the word. Okay, find the slope of the line that passes through the point 1, 3 and -2, -3, and then go ahead and graph the line. Okay, so let's go ahead and start with change in y over change in x. That's our slope. So here we've got 1, 3, and we've got -2, -3. So I'm going to go, let's go back to the basics. Here's x, y. This is x, y. Doesn't matter which one's 1, doesn't matter which one's 2, but I'm going to call this the 1s because those are first, and these are the 2s because they're seconds. So if you like, you can still do the y2 minus y1 over x2 minus x1. y2 is -3 minus y sub 1, which is 3, over x sub 2, which is -2, and x minus x sub 1, which is 1. So we have to be very careful with your negatives here, make sure we're doing the right math. All kinds of mistakes come out of this just because. -3 minus 3 is -6, -2 minus 1 is -3, -6 divided by -3 is just good old 2. So our slope, in this case, is equal to 2. They want us to graph the line. Let's go ahead and actually put this on the graph. 1, 3. Got it. -2, -3. Got it. Now let's go ahead and make our line. Oh, once again, I'm going to try to make a straight line. And once again, I should have arrows on the end of it, but here I go. Okay. Now, let's go ahead and do the rise over run method now that we've got it actually on the graph paper here. To get from this point to this point, I have to rise 1, 2, 3, 4, 5, 6 units, and I run 3 units, giving me a rise of 6, a run of 3, which comes out to be 2. So even if I do it on paper, I have a slope of 2. Please note, and you should always kind of double check yourself. Oh, this is an uphill line. If you're going left to right, you're going uphill. So this has a slope of 2. It is positive. You want to make sure that your number matches the kind of slope that you have. Okay? Part B, find the slope of the line -3, -1, and 3, 2. I actually want you to try this one on your own. Okay? I think I'm going to do another one next. Let me just double check here. So go ahead and do B, and then I'm going to do this one, example 2. Here we go. change in y over change in x, which is the same as y2 minus y1 over x2 minus x1, otherwise known as slope. Doesn't matter which one is which. I'm going to show you just even another way, which may be more confusing, I don't know. What's the change from 3 to 5? You have to add 2. What's your change from 2 to negative 1? You have to subtract 3. Your change in y is 2. Your change in x is negative 3. Okay, that's one way to do that. The other way is to actually use the formula. y2 is 5 minus y1, which is 3. x2 is negative 1 minus 2. So I have 2 over negative 3. Isn't 2 over negative 3 is the same as 2 over negative 3. It's also the same as negative 2 over 3, which is the same as negative 2 over 3. Refer to the graph below, which shows data on the fastest growing restaurant chain in the U.S. during the time period of the graph. Find the rate of change of the number of stores from 1999 to 2004. So 1999, right here. 2004, right here. Okay? It looks to me that in 1999, I always like to put time as my x-axis. Notice how it's on the x-axis. We're not going to call that a 5. I'm going to call that a 6. Okay? Notice how I'm writing out 1999. If you write out 99 and then you write out the number 4, that's not going to have any, it doesn't make sense in the context of our problem. So make sure when you're writing out 2004, otherwise you'll be taking 4 minus 1999. That doesn't make sense in this case. All right, and then this, I'm going to call that a 33. Okay, change in y over change in x. They want the rate of change. 33 minus 6, 2004 minus 1999. This gives me a 27, and 2004 minus 1999 is a 5. So I can leave it 27 over 5. You can go ahead and say that's 5 point, let's see, 2/5 would be 0.4. What do I label this? The rate of change is a change in y over change in x. The y value is the number in the thousands. So this is 5.4 thousand per year. So from 1999 to 2004, the average rate of change was 5.4 thousand per year. Find the slope of the line. Let's go ahead and use rise over run since we're looking at a graph. Okay, if we do that, what I like to do is find some corners. What I mean by a corner is a place where this line actually comes and crosses an intersection of the grid. Like there, and there, and there. Okay, now that I've got my points, now I can do my rise over run. From here to here, rise 1, run 2. Continue on, rise 1, run 2. Rise 1, run 2. So my slope, probably can't see that. The slope is rise 1, run 2. Slope is 1/2. I just got to show you this. If for some reason you want to start here and go to this one, you can rise -1 and run, when you're going left, you're running -2. Once again, I'm not doing this as Algebra 1, you guys. I'm hoping that you have the basics of this. Otherwise, I'd really slow down on this. So if you were to write that out, we never leave our answer -1 over -2. -1 over -2 is 1/2. It matches up. Now here's the other crazy thing. Whoa, watch out folks, because if I were to say, I want to find the slope from here to here, check it out. I could rise -3 and I could run -6. Well, if I were to write -3 over -6, that would reduce down to 1/2. Same as before. Same if I were to go like from here to here. I would rise 2, run 4. Rise 2, run 4. Rise 2, run 4 is 1/2. Okay, I think I've gotten that pretty clarified for you. Okay, find the slope. I'm going to do A and you're going to do part B. Here's A. The first one on A. Once again, find the corners. Once again, sometimes it's not perfect, especially up here in the graph. I believe that I wanted something like this here. Yeah, this looks about as good as my corners as I'm going to get. Okay, so I'm going to do rise over run. It's lots of fun. Okay, in this case, my rise from this point to this point is 3. My run, since I'm going left, is -2. By the way, when you're rising up, it's positive. Rising down is negative. Running right is positive. Running left is negative. I'm just going to leave that -3/2. Okay. Here's the interesting thing about this. You probably know from the earlier screen, the slope on this is undefined, but let's go ahead and put some points in there. Okay, let me show you why that is. If you take your rise from here to here, it's 2. Your run, there is no left and right. That's 0. If you take your calculator and take 2 divided by 0, you get error. This is when we write undefined, because 2 can't be divided by 0. So we have an undefined slope. You can abbreviate it, but that's it. You have no other option other than writing undefined slope. Okay, part B, you're going to do this one and this one on your own. And here we go with example 6. I also like to show tables, because tables are patterns, and we see patterns everywhere, and more than likely than if you're going to be out there in the world, you're going to have a pattern of something. Okay, this is when I love to use my change in y over change in x method. Okay, change in y over change in x. Now granted, you could just take 2 points. You could take this point and this point, which would be, I just want to write it out like this, which would be 0, 4, 1, 1. And you could go ahead and have a little heyday, do your y2 minus y1 over x2 minus x1, and then go do all that math. Yay, yay, yay. However, check this out. What is the change down the right column of this graph? -3, -3, -3, -3. What's the change over here? +1, +1, +1. So instead of doing all kinds of like minusing and I just say, hey, the change in the y value is -3, the change in the x value is 1, giving me a slope of -3. Okay, let's try it out on the next one. The change from here to here, +2, +2, +2. And it has to be a constant rate of change for this to work. What's the change over here? +5, +5, +5. So my change in y over my change in x becomes 2 over 5, 2/5. Here we go again. What's the change here? +1, +1, +1. What's the change here? +3, +3, +3. You could take 2 points if you want and do the old-fashioned, y2 minus y1 over x2 minus x1. I'm going for change in y, which is 1, over change in x, which is 3. Slope, 1/3. -2, -2, -2. Change here, +2, +2, +2. My slope, change in y is -2, change in x is +2. So I have a slope of -1. And we're done with this portion of lesson 2.3.